All right. If you are watching this, that means that I was unable to come to work on Tuesday. My little one is sick, so I am prepping this video just in case, or you were absent, and it is posted on my MCPS. So, if you'll go ahead and get out your packet and turn to page 8 with me. At any point during this, you can pause and catch up. I don't want you to make I don't want you to just copy down answers. That doesn't really help you. It's really important that you're trying it and then checking your answers. All right, so the pump up, it's saying use this triangle to the right to answer the following questions. So you're going to use this triangle over here and look from different perspectives and decide what are the ratios of the sides. All right, you want to name two ratios that are equal, one ratio that will give you a product of 1. If you multiply two different of ones together, they'll equal 1. And name two ratios that will give you a quotient that is equal to tangent. So that's an interesting one. All right, so take a few minutes, try that, and then we'll check some answers. Now, if you weren't ready, go ahead and hit pause, go back and try them, and then you can check your work. All right, so here are the ratios. If you're looking from A, so if we're looking from angle A, the ratio for sine is opposite over hypotenuse, so A over C. Cosine would be T over C, which is adjacent over hypotenuse. And tangent of A would be opposite over adjacent, right? So we're finding those sides, opposite and adjacent of angle A. And then if we're looking from this perspective, something happens. They're saying name two ratios that are equal. So if we're looking in the same triangle, sine of A ends up being the same ratio as cosine of T. Because here we're looking at the opposite, and here we're looking at the adjacent. So whatever this opposite side is the same as this one's adjacent side. So they end up being the same ratio. Same thing happens here for sine. Cosine of A ends up being equal to sine of the other perspective because the opposite and adjacent switch. And then here, tangent, they're saying if we multiply tangent of A times tangent of T, we end up with A times T and T times A times T. Anything over itself is equal to 1. Another way to get tangent is to take sine divided by cosine. So if we took the sine ratio and divided by the cosine ratio, the c's cancel out and you end up with A over T. So sine divided by cosine equals tangent. So that's kind of a neat factoid. All right, let's check our homework answers. Here are some homework answers. So this is the ratio. Here's the ratio simplified. We're just finding what is the ratio. All right, didn't ask us to find the angle. Just what is a simplified trig ratio for cosine of angle C. All right, check those out. See if you have any questions. All right, and then at the bottom of the page, it was asking you sine of this angle. Plug it in your calculator, you'll get one answer. If you look in the table, you're going to get a different answer. They're going to be more or less exact. The table is less exact. The table is more approximate, and the calculator is a little more precise. So here are some answers there. Here we had to work backwards and say if we know the decimal, if we know the ratio, what was the angle? And make sure that you clearly write degrees as part of your answer because this is an angle measure. We want to make sure we put that degree symbol in there. Okay, so that was last night's homework. Mark down if you have any questions that aren't getting answered today, and I will happily answer them tomorrow. All right, so this is the main lesson of the day. We want to find a missing side length. So if we know two little pieces, we can relate these three pieces of information with sine or cosine or tangent. We can find a missing variable. So here I know an angle, and I know this adjacent side, right? I know that's adjacent to this angle, this reference angle. And I know that this is the opposite side. So I have to figure out, okay, which trig ratio do I use, the opposite and the adjacent? No, it's not that one. Adjacent, hypotenuse, opposite, adjacent. So it looks like the first one we're going to use tangent, because tangent relates the opposite and adjacent side. So I'm going to start by writing tangent of 25 degrees is equal to the opposite, x, over the adjacent, over 10. Okay, I'm going to see if I can get closer. No, I can't. Okay. Sorry for my sloppy handwriting. Okay, so tangent of 25 degrees equals x over 10. This is a statement. We have one unknown, so we want to solve for x. In order to get x by itself, this is being divided by 10, so we're just going to multiply by 10 on both sides. Times 10 on both sides, and we get x is equal to 10 tangent of 25 degrees. Now if you're using your table of value, trig table, you can go to tangent of 25 degrees and get that 4-digit number, that decimal, and then multiply it by 10. Or if you're using a TI calculator, you can just type in tangent of 25 degrees. You want to make sure that you're in degree mode. Tangent of 25 degrees is that, and then we're going to go times 10. So it looks like that value right there, that height of that triangle is 4.66. 4.66. Now this is an approximate value. It's about 4.66 units tall. All right. It says round to the nearest hundredths. Let's check and make sure I rounded correctly. 4.663. So the 3 is not going to make that 6 turn any higher. It's going to stay at 6/6. All right. So how would I go about this one? You take a minute and try it. Decide which trig ratio you're going to use, sine, cosine, or tangent. All right, if you decided that cosine is the trig ratio you use, I would agree, because we're using the adjacent and the hypotenuse. So I want to set up that ratio. Cosine of 39 degrees, that does not mean times 39, it's cosine of an angle, not times an angle. Cosine of 39 degrees is equal to adjacent over hypotenuse, so x over 7. So this similarly is solved a very similar way. We're going to multiply both sides to get x by itself, times 7 times 7. All right, and the 7's cancel, and we get x equals 7 cosine 39 degrees. Now if I didn't have a calculator, I might just leave it like that, 7 cosine of 39 degrees. But I do have a calculator, so 7 times cosine of 39 degrees. Let's just check and make sure we get the same answer. If I said cosine of 39 degrees and times 7, I get the same answer. Okay, so if you want to put the 7 times cosine, that's fine. What if I did cosine of 39 degrees times 7? Would that be okay? Yeah, we still get the same answer. The only way we would not get the same answer is if we did cosine of 39 degrees times 7 degrees. So if we put that 7 inside with the angle, that would not give us a correct answer. So be careful, that 7 has to be outside of the cosine. All right, hopefully that didn't confuse anyone. Second entry, let's go fix that, delete, and times 7 on the outside. That is our answer for the second one. We want to round to the hundredths place, so 5.44. X is about 5.44. Now, this next one is where the really interesting stuff starts happening. So let's set this one up. What do we have? From this point of view, we've got the opposite side, and we've got the correct, the hypotenuse. Okay, so which of these are we going to use? Opposite and hypotenuse? Adjacent hypotenuse? Opposite? Okay, so we need to use sine for this one. So we're going to say sine of 46 degrees is equal to opposite over hypotenuse. So 8 over x. Aha! Sorry if I scared you. Okay, what is so different about this one? How does this differ from the last two? Do you want to pause and think about it? Alright, if you want to pause, go ahead. But in this case, here we have x in the numerator. Here we have x in the numerator. In this case, now our x is in the denominator. So it's going to take us an extra step to solve this. So I can't just multiply by 8 on both sides. That would not simplify or get rid of 8. And it wouldn't help x get out of the denominator. So in order to clear x from the denominator, I'm going to multiply by x. So I'm multiplying by x. That clears it out here. So we get 8 equals x sine of 46. So x times the sine of 46 degrees equals 8, right? We cleared out that x. Now we want to get x by itself. That is our goal. Get x alone. And right now x is attached to the sine of 46 degrees. So we're going to divide both sides by sine of 46 degrees. I'm just going to take a picture of it. Click. Ooh, where'd it go? Sine of 46 degrees. I lost it. Oh, there it is. It's hiding. There it is. Woohoo! Okay, so we're going to divide both sides by sine of 46 degrees. So that's going to cancel out. It's going to cancel out sine of 46, and what's left here is x. And what's here, now again, we're kind of approximating this. Now we need to take 8 divided by sine of 46 degrees. 8 divided by sine of 46 degrees. And I get 11.12. 11.12. So I would say x is about 11.12. We are rounding here, so it's approximate. All right. So we did those three together. I want you to take a few minutes, try 4, 5, and 6, and then I'll show you some answers. All right. I would like you to hit pause and try those. Thanks. All right. If you didn't give yourself time to try them, please rewind the video. Give yourself some time. Try 16, 17, 18, and then come back and check this. So sometimes you have x in the denominator. Sometimes you'll have it in the numerator. When x is in the denominator, it takes a couple extra steps. We have to first multiply by x, and then divide by the trig function. All right. Okay. And all of these signs really should be approximate signs because we're rounding. Whenever we round, we're approximating our answer. It's not an exact answer. All right. So hopefully you got those. If you didn't, maybe these steps can help you see what you did incorrectly. All right. So there is some extra practice here. But these are a little different. Okay. So here we're finding the missing side length, but now they're asking find the missing angle measure. Okay. So now we have to relate. It's a little different. All right. So we're going to say, all right, from this angle, we know the adjacent and the the adjacent and the hypotenuse. So here's my adjacent side. That one confused me a little. This is the longest side, so this is the hypotenuse. So adjacent hypotenuse, that looks like cosine. All right, so I'm going to write out cosine of theta, my unknown, right? Cosine of some angle measure is going to equal 12 over 13. Okay, now we looked at this yesterday and we figured this out. Now you could put this into your calculator, write a 4-digit decimal, and find it in that table. All right, now if you're using the calculator, what we're going to do is we're going to do the inverse of cosine to get that theta out of there. So in order to free up this variable, this is cosine of theta. We need to do the inverse cosine. So I'm going to take the inverse cosine of both sides, the inverse cosine undoes cosine, and I'm going to do the inverse cosine of this side as well. Inverse cosine of this. So cosine and inverse cosine cancel each other out. Theta is what I have on this side. And again, it's kind of approximate, we're rounding. Inverse cosine, so I'm going to type that in my calculator. Cosine inverse of 12/13. Okay, so we're going to go to our calculator, clear that out. Okay, so here I have cosine, here I have inverse cosine. You see my wiggle right here, it's blue, it's right above. So I need to hit my second key and hit inverse cosine of 12 divided by 13. And that will give me, make sure you're in degree mode, that will give me the degree measure of that angle. So if I know the ratio, I can find the degree. So theta is approximately 22.6, and it said round to the nearest hundredths. So 22.62. 22.62 degrees. Make sure you're writing degrees in there. All right. Great. So, should we try one more? We'll try one more together, and then you guys can take off on your own. Okay. So here, we're looking from this angle, theta. We've got opposite, and we've got adjacent. So it looks like I'm going to use tangent. All right. So we got tangent. So opposite and adjacent, so tan of theta, tangent of theta equals opposite 4/13 adjacent. Okay, I'm going to do the inverse tangent of both sides. When I do, theta frees itself from tangent, and I do inverse tangent with this -1. It's not really an exponent, but it kind of is up where the exponent lives. So inverse tangent of 4/13. 4/13. All right, so I'm going to find my calculator and go inverse tan of 4/13. And I get 17.1. So theta is approximately 17.10. 17.10 degrees. All right. Now, if I was using my trig table, I would type in 4/13. So 4 divided by 13. I would find that decimal, so that 4-digit number would be 0.30. Uh-oh, where's my number? 0.3077. 77. And I need to go find my trig table from yesterday or today's. Okay, let's go find our trig table and copy that and bring it over here. Okay, so if I look at my trig table, we're on the tangent function, and I need to find that 0.3077. So go over here. If you don't have a calculator, you can look at your table and say 0.30 on the tangent, 0.3077. Now I just have to find the closest value, and it looks like the closest value is 17 degrees. No, it's not, it's less precise, right? Here I got something more accurate, but this 17 degrees would be close enough. Okay? So if you don't have a calculator, you may also use the trig table and work backwards. Using the ratio, you can find the angle. Okay? Alright, so that is the majority of what today's lesson is. I'm going to show you the answers to all of these, so you can hit pause and try a couple and make sure you're okay with that. So here are those answers. If you haven't done them yet, hit pause, back up a minute so they're not showing, then you can check your answers. Okay. Alright, there's one other thing, if you have time, is this. It's saying sketch 3 different right triangles with one side measuring 7.5 and one angle of 36 degrees. So 7.5 could be this side, or 7.5 could be the hypotenuse, or 7.5 could be this side, right? And the angle measuring 36 degrees, so let's say 36 degrees is this angle. So let's duplicate and make it that angle. So I just want to clarify, these would be 3 totally different triangles. Even though they have the same angle measure, this has this leg of 7.5, this has this leg of 7.5, and this has the hypotenuse of 7.5. So you can go, just knowing those 2 pieces, you could then say, oh hey, what if this was x, and solve for that side? What if this was y, and solve for that? You can also find this other angle by process of elimination, or the triangle sum theorem states that 180 degrees inside that triangle. Okay? You also have homework number 2, so this is a good activity, and homework number 2. Alright, thank you so much for watching. Have a great day. I'm sorry I was unable to be in class. Alright, see you Wednesday.